Turn to a topic we had in the first day, meteorites, so the solid stuff is coming here. Gerhard reports about his kind of investigation of meteorites.
One, two, three, that's better now. Okay. Yeah, thank you very much. So we had a lot of information about meteorites in the very first session. It was about the Riebeck fall. And I will talk about a more general topic about meteorites. It's an amateur's approach to the identification of meteorites. So the amateur, that's me, the first one here. Then we have Arne Boersma. He is a bachelor student who supported me. And I also asked him to just look at some statistics. For example, is there a seasonal dependence of meteorite falls? And in the very last slide, I will show what he found. You can think about it. Is it more in the winter, in the summer? When do most meteorites fall? And then there is Björn Poppe, who is the head of the division where we are working in. Actually, I'm just supporting this. So again, it's an approach of semi-experts, let's say. We have some knowledge, we believe, to analyze good meteorite candidates sent to us. So here's a question is, if someone finds something on the ground and thinks, oh, could this a meteorite? Because it is in the news a lot, and I bet most of you have been contacted sooner or later. Oh, I found a stone, could this be a meteorite? And we thought, could we do something to at least exclude, for example, that something that is sent to us is really a meteorite. And I will present some methods we use. You see some examples here. These are stones sent to us, where we could not, by looking at the pictures, immediately exclude that these are meteorites. We thought, okay, it's worth to look at them a little bit more in detail. And you see there could be a black and smooth and eroded. It's fines. We are talking about fines, and fines in Germany. That means there will have been on the ground quite some time. So you have to expect quite some erosion. You don't get normally a smooth fusion crust. They will look very different from what a very fresh meteorite might look like. And we have a website for the general public on how to identify a meteorite. First of all, it is in German, so it's really addressing the German population. Otherwise, it would also completely get out of hand. And it includes a link to send pictures and information about the potential meteorite find. And here is a link at this university. So if you type in, for example, in Google, Meteorite erkennen oder Meteorite identifizieren, then you get this entry, our website, as a top entry in Google. Actually, the second entry is the one from Dieter Heinlein from the DLR. He also has a similar website. And perhaps it was a bad idea because it causes us lots of work. A lot of people are really picking this up. And we introduced this website when there was a potential fall indicated by Frippon network, a strewn field. And we went out there for a brief search that was close to Oldenburg. We didn't find anything. And then we thought, oh, let's make a website and alert the public. Maybe someone finds something. And we have this website. But since then, and we left it, we get meteorites sent or candidates sent from all over Germany. And I think it's some sort of reverse citizen science project. It's not one person asking many citizens to support his analysis. Here, many citizens sent it to one person to ask, oh, did you find something there? And here is the procedure. If we get an inquiry, first of all, inquiry, normally it says on the website there are some information how to identify a meteorite on this website, but certainly some people ignore it, and some people also read it and say, okay, everything fits. I'm not going in details what is said there. But then if they think there is something, they send us, we ask for some pictures or some videos. And looking at those, I would say in 90%, I can immediately exclude and identify them as meteor wrongs. But in 10%, that's not the case. So if this cannot be done immediately, there are several possibilities. I often also ask Dieter Heinlein for his expertise. He's very good in recognizing them, has much more experience than we have. And then I say, I could suggest to find someone to do an RFA analysis. I realize in English it means XRF. So for X-ray fluorescence analysis. And also I should mention that we can in this way, because to do an RF analysis, normally it's good if the object is metallic, so if it's magnetic, and then you can easily analyze it. If we find if there would be a rare type, like the Albright, the Ribbeck, we would not be able to identify it. Also, by looking at it, I would probably never have sent this to us. I mean, it's really more for normal stones, but most of them are ordinary chondrites. Actually, I brought 2 here, of which I will show a bit more of the analysis. So this is just what I'm mentioning. And some people say, oh yeah, it fulfills all the requirements on the website, but it is not magnetic. But I read it could be a lunar or Martian meteorites, not magnetic, and we still would like to send it to you. We are not accepting this, that we would not be able to identify really a lunar meteorite. Okay, but if it looks okay, then I could offer to send the probe to us. And if people do this, here are typical pictures of meteor wrongs, let's say, of objects. Some of those have been sent to us, but most are not. And I would say the most common meteor wrong is something like this, which is slag. It could be magnetic and look metallic, but you see often some outgassing holes. Or it could be some just iron junk. It's magnetic as well. It could be just iron junk. It could be a rest of ammunition from the World War, and so you find a lot of those. It is rusty, which is also okay. If it's completely black, that's also not a good indication for something that has been in the ground and that contains iron. You see some others. This is magnetic. It's not such a good resolution. That's magnetite, which is also quite common in Germany. It's also magnetic. It looks blackish, but it normally has some sharp edges. Some others are not so obvious. Okay, this is probably a pyrit nodule, and also you get sometimes a whole selection of those which are more limestone or something quite obvious that you can reject it. Actually, I thought also this doesn't really look to me like a meteorite. I thought maybe we should involve some artificial intelligence to at least help to identify the 90%, which I can exclude immediately. If I can do it, then maybe in the coming time, it should also be able to do this automatically. So there was one very odd case. We had many very odd cases, but I would just like to mention this one. And you remember there was in 2023 this meteorite fall in Elmshorn near Hamburg in Germany. And then I got contacted by the police in Elmshorn just a little later. And they said someone had filed a claim that a meteorite worth about 5,000 euros was stolen from his garden in Elmshorn. He sent some pictures, this is one of them, and the stone also had not been analyzed, he claimed, but he still went to the police and claimed, oh, someone stole my meteorite. And they asked whether from the pictures alone I could tell perhaps if this could be a true meteorite and it could be worth 5,000 euros. I told them this was an easy answer because I estimated the worth of this slag at less than 50 cents. It's obviously a piece of slag, which is quite common in the Elmshorn area. And I know you can easily mistake it. It's black. It's probably not magnetic. I don't even know. But you see, you sometimes get funny inquiries. Also from the Ribbeck fall, we got several pieces sent, and which normally I would have rejected, but because it was a very strange looking one, I had them sent. But obviously those were not meteorites either. And I bet we heard a lot of success stories in the first presentations, but I bet there were a lot of stones which were not real Ribbeck meteorites that you bent down and picked up when you collected them. So those two sent to us were not real meteorites. Okay, but let's now look, what do we do if we get something really sent, where we think there is a chance that it is a true meteorite? Here's one, an ordinary chondrite, unclassified, from Northwest Africa, so somehow we're from the Sahara. And that's a piece that I brought here. So, and we tested several methods on this piece, just to see can we identify it. So mainly what we do is we look for nickel, for iron and nickel, and no other heavy elements, because there are of course alloys which could contain both, but naturally iron and nickel doesn't happen really easily together. So we have this piece, and one first step is often we might have to cut a probe. If only a small probe can be analyzed by the equipment we can use at the university. So you see here, an expert, actually I asked all those people and companies I'm mentioning to get permission to show this. So here you see this stone that I have here is cut to get a smaller piece. And there is a water-cooled diamond saw we have at the university. It's mainly used for glass cutting. And so he was cutting this. Then the first analysis method is often to use just this X-ray gun, the XRF method, and that's very efficient and goes very fast. So you see here is this stone, this ordinary meteorite, the same one I have here, and here is this device he used, and he get immediately some results. If you look carefully on this one, you can see, I will show the numbers a little later, 87% iron and 9.5% nickel it has. It always, it only analyzes certain elements and normalizes them so that you get 100%. You see, here's a guy doing it, and this is actually done in the scrapyard, Springer und Sohn in Oldenburg. You see, this guy is doing it often. He has this gun in his hand. It goes very quickly in a few seconds. And you also can see this is not exactly a clean room. It's a scrapyard, but that's all you need. And it goes within seconds. Then we also have a jeweler, Gabriel. He's shown here. That's the father of this company. So, and they have a high reliability X-ray device equipment. And they also can do these XRF tests. You see here is the equipment. There you have to have a smaller sample. That's why we cut this sample. It's highly reliable. They mainly look for gold and platinum and so, but they also can analyze the other heavy elements. And this equipment apparently costs about 40,000 euros, while this XRF gun costs about 20,000 euros. But it more or less, it uses the same principle, and here are then some results displayed, and you clearly can identify nickel. Then we have at our university a more recent method, which is an SEM EDX analysis at the university. This equipment is fairly new. They say it costs 800,000 euros. You can use it also for relatively small samples, and this goes also to lighter elements. So you can also have carbon and nitrogen and oxygen, which the other ones do not register because they just go for the heavy metals. And but this is a bit an overkill. First of all, it has to be done under vacuum. That means it takes sometimes like 45 minutes to get the proper vacuum, because these samples, they outgas like hell. So that is quite surprising. It's mainly used for biological samples and so on. But you can do exciting things if you would know how to handle it. So you get a spectrum after some time. You also can do a 2D scan and get a scan for various elements. So you get them displayed at the same time. The scanning area, you can zoom a bit in. You get a photograph. Here it's about 1 millimeter by 1 millimeter. And you can get a lot of information, but mainly we are interested in, with our expertise, is there iron and nickel and not many other heavy elements. So here is now, I'm coming to the last 2 minutes. For this unclassified ordinary chondrite, some results using the various methods. And I'm just showing those for iron, nickel, and cobalt. You see here, if you use this X-ray gun for 10 seconds, it just looks for the heavy elements. You get this distribution. If you use the same gun for 35 seconds, I think after something like 15 seconds, it switches over to also record some lighter elements. It does this automatically, and it gets stable at about 30 seconds. Then you get a different relative distribution. So the other percentage is in lighter elements, which I don't show here. Here we went to the jeweler with his, and we looked, because that's very fine, at the metal corn. You get this distribution. And here is a different one where we looked at the matrix of these ordinary chondrites. So it also depends a bit where you look. This is less sensitive to the position. And our EDX study, it has much lower values, but it has a range of nickel. It's clearly a peak because it has a lot of these lighter elements which are in it. So it really depends. You have to understand your equipment and how long you apply it and what the percentages mean. But in any case, nickel was identified. I see I have to come to an end. And I will. Here are some statistics. We received about 1,500 inquiries so far, including pictures. We suggested about 140 to do an RFA. And we offered to do an analysis by us to send us a sample to about 40. And 20 were about actually sent. And meteorites identified 1. And this was only about 10 days ago. So before I had put 0. And this is an iron meteorite. It's clearly a meteorite, but we still have to find out, was it really a genuine one, or how did I identify it? But we found 1 out of 1,500. I see I'm running out of time. So I'm coming to the very last slide that I mentioned, the distribution, the seasonal distribution. And this is what we found at this website that I give here. So you see the numbers are not too high, but there seemed to be a peak here. It could be a bit artificial in the summer, in July. And it's from the period 2000 to 2023. So Ribak is not included here. It seems to be fairly flat. We have a second distribution from all those meteorites in the MET catalog, which are 5 times more. And there you don't have this peak, but some broad peak around the summer. But in general, it seems to be rather flat and not pronounced peaks. Thank you for your attention.
Thank you very much. I think 1 of 1,500 is better than Dieter Heinlein often claims.
Well, if I could add to this, Dieter Heinlein, I asked, he said he had about 4,500 inquiries. He has run his site longer, and we have 1,500, and he identified 3. So if I upuse statistics, I can say every 1,500 inquiries, you find 1.
Okay. Questions, just brief questions, please.
Yes, very nice talk. We do something similar in the Netherlands, in the Dutch language, and it is a huge job if you want to do it correctly. So I'm very impressed how much time you can devote to it. I'm curious about one question which they often ask to us: what is it worse? And if they do the same question firing to you, I'm wondering, what do you answer?
Well, normally we keep it vague or do not answer at all. We say we are not making estimations, and also we are not willing to buy something. We are not a dealer, so I try to avoid answering these questions. I sometimes say if it's found in the desert, maybe it's 20, 30 cent per gram. But if it would be found in Germany as a new one, of course, it's could have a totally different value as a special case when you find it in your country. But I'm trying to avoid, we get these inquiries, but I try to avoid that question. On the mineral show, you know what you can buy them for, but if you find it, it's a different story.
Okay, thanks once more. We have to keep on. Thank you.